Here we are, the final lesson of the semester. And this should say day 11 notes. Sorry, should be corrected. Day 11 notes. First, we're going to review function families. So it's been a while since we talked about this. So this first one is a linear equation. And this is just y equals x. So in other words, if x is 1, y is 1. If x is 2, y is 2. If x is negative 1, y is negative 1. Same number. X is equal to y is equal to x. Here, we have exponential growth. And our parent function is y is equal to 2 to the x. We use 2 as our base for our parent function. Function family here is a quadratic. Our function parent equation is y equals x squared. That's with no transformations, which is why we have 0 equals 0 right here. And so 0, 0 is right here. And if we go to 1, we get 1. If we go to 2, we get 4, and so forth. This is a square root function. And so our parent function is y equals the square root of x. So the square root of 4 is 2, square root of 9 is 3, and so forth. Our snake, that's our cubic function. And that is y equals x cubed, x to the third power. So again, we have 1 equals 1, but now 2 shoots all the way up to 8. Next one here is v. Remember our v, classic v, okay? And v is for absolute value. V for value is our way to remember it. And so we have y equals the absolute value of x. So 1, absolute value of 1 is 1, but the absolute value of negative 1 is also 1. And the absolute value of 2 is 4, but the absolute value of negative 2 is also 4. Equal on both sides. And here we have a logarithm. And our base for that is log base 2 of x. All right, matching. So right here we have a little 3 here, so that's cubic. Here we have our absolute value bars, so that's E absolute value. A little 2 here, that is quadratic. X to the 1, that is C linear. 5 to the x, that's exponential, technically exponential growth. Here we have a square root symbol, so not too challenging there. That's square root. And then we have the word log, so not too tricky again. Logarithmic g. Now, this is just a review of what we've done in the past. If we have plus outside of parentheses, just add on an extra amount. So we have our parabola, say x squared, but then we're going to add the c. That's going to move it up that many spaces. If we have minus, that's going to move it down. Now, if we go inside parentheses, here and here, remember, this is where we go opposite. Okay? So these two are tricky because we go opposite of what we're thinking. Or remember, another way to do it is set it equal to 0. So if this was x plus 5 in the parentheses, and we set it equal to 0, we would get x equals negative 5. And now here, if we had x minus 2 inside parentheses, and we set that equal to 0, we would get x equals positive 2. So one way to think about it is go opposite. Positive 5 becomes negative 5. Negative 2 becomes positive 2. Or set them equal to 0. Okay. A number in front, like so, stretches it vertically. Okay? That means it's going to pull it top to bottom. That also makes it thinner. We've also referred to it that way. If we have a fraction less than 1 in front as our coefficient, that's going to compress it vertically, which is going to squash it or make it wider. And if we have a negative in front of our function, then it's going to reflect over the x-axis, or we talk about flipping it. So, A, let's find A. A is right here. That is exponential decay. Okay, not exponential growth, this is decay right here. So, knowing that it's decay, that means we're looking for an exponential where x is in the exponent spot. And since it's less than 1, that is decay. B, that's exponential growth. That's the word growth, believe it or not. So again, exponential, we're looking for x in the exponent spot. So that's B. C is just a straight linear equation. So that's y equals x, y equals 2x, y equals 1/2 x plus 5, or 3x plus 1/2. Therefore, this is C. And D, we have a logarithmic equation. We look for the word log. That is D. All right, remember, when solving systems, the following situations, which we have common here, can occur when finding solutions. So, if I have a parabola and this linear equation just touches at one spot, we have one solution. Here we have an exponential growth and a line, a linear equation passing through it, hitting it at two spots, two solutions. Or we could have something like the third example where we have a logarithmic equation and a line that's never going to hit it anywhere, and therefore we have no solution. Now, solve the system of equations algebraically using substitution or elimination, then check by graphing. Okay? Well, this one to me screams out substitution because they're already both solved for y, which literally means you're just going to take this and plug it in here. So you're just setting them equal to each other. X squared minus 4 equals 2x minus 1. Once I see the x squared, I know I need to get everything on the same side. So that's going to be x squared minus 2x. When I add the 1 to move it over, that's going to give me minus 3 equals 0. Now I factor. I always factor when I have x squared. I need two numbers that multiply to give me 3, which the only choice is 3 and 1. But they got to differ by 2. Well, 3 minus 1 is 2. But also notice I want more negatives left over, so that's going to be minus 3 and plus 1. I'm going to set them both equal to 0. Remember, these are my x solution. These are just part of 2 points. So I'm going to have 2 points here. -1 and 3. Now what I need to do is I need to plug -1 into either equation and 3 into either equation. The easiest one is going to be 2x minus 1. So I'm going to plug in y equals 2 times -1 minus 1, and y equals 2 times 3 minus 1. This is going to give me -2 minus 1, so -3, that's y. And 2 times 3 is 6 minus 1, that's 5. So when when x is -1, y is -3. When x is 3, y is 5. So -1, -3 is going to be a point of intersection. And 3, 5 is going to be a point of intersection. Now, I am going to graph my 2 equations. Now remember, we have a calculator, so why not, let's make life easier. And I'm going to put x squared minus 4 in my graphing calculator and get some points. For some reason this is not running. Sorry, my graphing calculator won't pull up. So I'm going to put in x squared minus 4. Hit graph. Oh, look at that. What do we do in this situation when it doesn't graph correctly? We do zoom 6. Now I'm going to go to my table and get some points. So, yeah, x squared minus 4. So, there we go. I'm going to put these points in the graph. Now, that means my parabola is going to be at 0, 0, -1, we know is going to be at this point right here. Of course, I'm not thinking, sorry, it's not going to be a net 0, 0 because it's dropped down. Silly me. So 0, -4 is going to be a point. If I put 1 in, I'm also going to get -3. If I put 2 in, that's going to be there. If I put 3 in, I'm going to get this point right here. And -3 is also going to give me 5. And 4 is going to give me 12, and -4 is going to give me 12. And so here is my parabola. Keep an eye on those 2 points. They're also black for the dots. Now I'm going to graph my line 2x minus 1. That means a -1 intercept, and up 2, right 1, up 2, right 1, up 2, right 1. Look at that spot where the black and red are. Now blue. So down to, oh, look at there, down to left 1, down to left 1, down to left 1. And so here is my line. Now where did they cross? Right here and right here. At 3, 5 and -1, 3. That's the solution to the system. The line, the linear equation, crosses the parabola in 2 spots. Which again was this situation right here. 2 solutions. Alright, and that's it. Alright, so last page. It says solve using substitution or elimination. Well, with this situation, they're both set equal to y, so you're literally just going to say 3 to the x minus 5 equals 4. Add 5 to both sides. 3 to the x equals 9. And then you could change this to the same base if you wanted to, 3 squared, or you should just go 3 squared is 9. So x equals 2. So x is 2. What's y going to be? Well, we plug 2 in here, which we've already done. We know it's 4. So they should intersect at 2, 4. Let's see if they do. So y equals 4. Number is a horizontal line going through 4, because y is always 4. And then for 3 to the x minus 5, use our handy-dandy calculator and put it in and get some points. So y equals, clear out whatever you got in there, 3 to the power of x. Make sure you come down, and it was minus 5. And we're going to graph. Oop. Zoom 6. Something's not working. There we go. So we have exponential growth, and it's going to come up and hit. So we go to our table, get a few points. 0, -4, 1, -2. 2, 4. We knew it was going to hit. So 1, -2 is going to be right here. We know it's never going to hit the asymptote right here at -5. So it's going to ride along that line, turn up, and intersect right here at 2, 4. Moving on. Now it just says use the graphing calculator. So we're good to go. Of course, just pull this up. I'm going to change 2 to the x minus 2. 2 to the x minus 2. And hit graph. So it's never going to hit -2. So let's get some points now. So we got 0, -1, 1, 0. 2, 2, 3, 6. And 4 was off the chart up here, about 14. And again, it's never going to hit -2, because that's where the asymptote is. So it's going to ride along that line and come up like so. Okay, so this is going to be really 1.5x. So we're starting at 0, 0. We're going to go up 1.5 over 1. We're going to go up 1.5 to 3 over 1. Up 1.5, 3 over 1. You can see it's going to intersect somewhere around there. Not exactly on a point, so we're going to have to use a calculator from here on out. So I'm going to draw my line. I'm also going to go down 1.5, 1 over here, and it's going to be somewhere like that. So we're having an intersection here and here. We need to find out what they are. That's where the calculator comes in handy. So we're going to put both of these into y equals. We're going to add the second one. And then what we're going to do is we're going to hit second calculate, which is trace. We're going to calculate it. And we're going to go to number 5 for the intersect. And you're just going to move this little bubble ant down near it and hit enter 3 times. And there's our first point, -1, -1.5. And now we're going to repeat. So we're going to go to second calculate, intersect, come up to the other point of intersection, just close to it, as close as possible, and then enter 3 times. And we have about 2.5, 3.8. Which makes sense because it's not quite on a corner point. And last but not least, we're going to put this in our calculator. Now the first one we don't have to really worry about. It has a y-intercept of 6. We're going to still put in the calculator for the intersection point. And it's going to have a slope of -1. So down 1, right 1, so forth, up 1, left 1. And it's just going to come down like so. Beautiful, not so straight line. Okay? Then log 2 of x. We're going to use our calculator for that. Clear it out. Going to hit log, go to math, go up to log base, and put in 2, go over and put x. Clear this out. We're going to hit graph. So there's our log function right there. We're going to get some points off the calculator. 1, 0, 2, 1. Four, 2. Okay. And we're going to be having it looking something like so. Now, to find the actual points of intersection, we're going to put in our second one, which was, again, negative x plus 6. Negative x plus 6. Hit graph. And we're going to do second calculate, trace again. 5 for the intersection. Go to where we think it's going to hit. And we hit enter 3 times. And there it is at 4, 2, which we can clearly see from our drawing, it did hit at 4, 2. And that's it.